Hi everyone, this is Kavitha from Computer Science Department, A.D.M. College for Women, Nagapattinam. Today's topic is data warehouse. Data warehousing and OLAP technology for data mining. Content: what is a data warehouse? A multi-dimensional data model, data warehouse architecture, data warehouse implementation, further development of data cube technology from data warehousing to data mining. First one, what is data warehouse? That means a decision support database that is maintained separately from the organization's operational database. Support information processing by providing a solid platform of consolidated historical data for analysis. A data warehouse, it is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management decision-making process. The process of constructing and using data warehouses. Data warehouse, which is a subject-oriented, organized around major subjects such as customer, product and sales. It is focusing on the modeling and analysis of data for decision makers, not on a daily operation or transaction processing. It provides a simple and conscious view around particular subject issues by excluding data that are not useful in the decision support process. Data warehouse integrated is constructed by integrating multiple heterogeneous data source, relational databases, flat files, online transaction records. Data cleaning and data integrity techniques are applied. Ensure consistency in naming, conventions, encoding structures, attribute measures, etc. among different data sources. Its example: hotel price, currency, tax, breakfast covered, etc. When data is moved to the warehouse, which is a converted. Data warehouse time variant. The time horizon for the data warehouse is significantly longer than that of operational systems. Operational database, there is a current value data. Data warehouse data, which is provide information from a historical perspective. For example, past 5 to 10 years data. Every key structure in the data warehouse, it contains an element of time explicitly or implicitly, but the key of operational data may or may not contain time element. Data warehouse is a non-volatile, a physical separate store of data transferred from the operational environment. Operational update of data does not occur in the data warehouse environment, does not require transaction processing, recovery and concurrency control mechanisms. Requires only two operations in data accessing, that is initial loading of data and access of data. Second one is traditional heterogeneous database integration. Build wrappers, mediators on top of heterogeneous database. This is a query-driven approach. When a query is posted to a client side, a metadata dictionary is used to translate the query into queries appropriate for a individual heterogeneous site involved, and the result is integrated in a global answer set. Complex information filtering compared for resources. Data warehouse update driven or high performance. Information from heterogeneous sources integrated in advance and stored in warehouses for direct query and analysis. Data warehouse with operational database. First one, OLTP. OLTP means online transaction processing. It is a major task of traditional database and relational database DBMS. Day-to-day operations: purchasing, inventory, banking, manufacturing, payroll, registration, accounting, etc. Next, OLAP. OLAP means online analytical processing. It is a major task of data warehouse system, data analysis and decision making. Difference between OLAP and OLTP. Both are user and system orientation, customer with market. Data contents current, detailed with historical consolidated. Database design, ER plus application with store plus subject. View, current local with evolutionary integrated. Access pattern, update with read only but which is a complex queries. OLTP with OLAP. User function database design. OLTP is a clerk, IT professional, day-to-day operations. OLAP means knowledge worker, decision support, subject oriented or historical summarized. Usage access. It will say in OLTP, read and write index as a prime key. For OLAP, there are lots of scans. Unit of work, record, access, uses. Which is in OLTP, short, simple transaction and thousands to tens. Complex OLAP, complex query, millions and hundreds. And database size in OLTP 100 MB to GB, in OLAP 100 GB to TP. Metric, transaction throughout, which is the query throughput response in OLAP. Why separate data warehouses? It's a high performance for both systems. DBMS turned for OLTP, access method, indexing, concurrency, recovery. Warehouse turned for OLAP, complex OLAP queries, multi-dimensional views and consolidation. Different functions and different data. Missing data, data consolidation, data query. Missing data means decision support requires historical data which is operational. DBMS do not try typically maintain. Data consolidation. Data DS requires consolidation, that is aggregation, summarization of data from heterogeneous sources. Data quality. Different sources typically use inconsistent data, repetitions, codes and formats which have to be recorded. Conceptual modeling of data warehouse. What is the conceptual modeling data warehouse? Which the dimensions are measured. Star schema, snowflake schema, fact consultation. Star schema, it is nothing but a fact table in the middle connected to a set of dimension tables. Snowflake schema, a refinement of star schema where some dimensional hierarchy is normalized into a set of smaller dimension tables forming a shape similar to snowflake. For a fact consultation is a multiple fact tables shared dimension tables viewed as a collection of stars, therefore called a galaxy schema of stars. Fact consultation. Measures. There are three categories in measures: distributive, algebraic, holistic. Distributive means if the result desired by applying the function to n aggregate value in the same as the derived by applying the function on all the data with partitioning. Example: count, sum, minimum or max. Algebraic, if it can be computed by an algebraic function with m argument, each of which is obtained by applying a distributive aggregative function. Example: average of min n, standard deviation. Holistic, if there is no constant bound on the storage size needed to describe a sub-aggregate. Example: median, mode, rank. Is the concept of hierarchy, dimension, location. View of warehouses and hierarchies. Multi-dimensional data. This is the diagram. Sales volume is function of product, month and region. A sample data cube. That is the product, total annual sales of TV in US. Cuboids corresponding to the cube. All products. Browsing a data cube. How to browse the data in data cube. Visualization OLAP. Typical OLAP operations. What are the operations in OLAP? Roll up, drill down, slice and dice, pivot, other operations. Roll up means the summarized data by climbing up hierarchy or by dimension reduction. Drill down is the reverse of roll up, from higher level summary to lower level summary. Slice and dice means project and select. Pivot, that is a rotate the cube visualization to 3D to 2D planes. Other operations: drill across, drill through. Drill across means involving more than one fact table through the bottom level of the cube to its back and relation labels. It is a star net query model. Shipping method output. Next one, data warehouse architecture. Here, design of data warehouse. There is a business analytical framework. There are four views regarding to the data warehouse. There is a top-down view, data source view, data warehouse view, and business query view. Top-down view means allows selection of relevant information necessary for the data warehouse. Data source view exposes the information being captured, stored, and managed by operational systems. Data warehouse view means Consists of fact tables and dimension tables. Data warehouse design process. Top down, bottom up. Top down, bottom up approaches are a combination of both. Top down starts with overall design and planning. Bottom starts with experimental and prototypes. From software engineering point of view, waterfall and spiral. Spiral means rapid generation of increasingly functional system, short turnaround time, quick turn and around. Typical data warehouse design process means choose a business process to model. That is example, orders, invoice and etc. Choose the gain of the business process. Choose the dimension that will apply to each fact table record. Choose the measure that will populate each fact table record. Multi-tiered architecture. That is a DBMS and data mods and analyst query, reports, data mining, data source, data storage. Three data warehouse models. What are the three data warehouse means? Enterprise data warehouse, data mod, virtual warehouse. Enterprise data warehouse means collect of the information about subject plus spanning the entire organization. Data mod means a subset of corporate-wide data, that is value of a specific group of users. Virtual warehouse, a set of views over operational databases. Only some of the possible summary views may be materialized. Data warehouse development. A recommended approach is distributed data mods to multi-tier data warehouses. This is the high-level corporate data model. OLAP server architecture. Relational OLAP. Use a relational or extended relational database to store and manage warehouse data and OLAP middleware to supporting missing pieces. Include optimization of database backend, implementation of aggregation, navigation logic and additional tools and services. Multi-dimensional means array-based multi-dimensional storage engine. Fast indexing to pre-computer summarized data. Hybrid OLAP means user flexibility, that is the low level, high level and relational IA. Specialized SQL server means it supports for SQL queries over store and Snowflake schemas. Data warehouse implementation. Back to implementation data warehouse. Efficient data cube computation. Data cube can be viewed as a lattice of cuboids. The bottom most cuboid is base cuboid. The topmost cuboid approximately contains only one cell. Metallization of data cube. It is every cuboid or some partial metallization. Selection of which cuboids to metallize. That is based on size, sharing, access frequency, etc. Cube operation. Cube definition and computation in DMQL. Define cube sales item, city, year of sum of sales in dollars. Cube computation ROLAP based method. Efficient cube computation method ROLAP, which is based cubing algorithms. There is Agarwal Extron in 96. Array based cubing algorithms, bottom up computation methods. ROLAP based cubing algorithms, sorting, hashing and grouping operations are applied to the dimension attribute in order to record and cluster the tuples. Grouping is performed on some sub-aggregate as a partial group step. Aggregates may be computed from previously computed aggregates rather than from the base fact table. Multi-way array aggregate for cube computation. What is the best traversing order to do multi-way aggregation? Is a partition array into chunks. There is a small subcube which is fixed into memory. Comprise sparse array addressing. There is a chunk ID offset. Compute aggregation in multi-way by visiting cube cells in order which minimize the hash of time to visit the cell, each cell, and reduces memory access and store the cost. Multi-way array aggregation cube computation is a diagram. Computation is an array diagram. Multi-way array aggregation for cube computation. Method. Limitation of the method. Method means the plane should be stored and computed according to other size in the ascending order. That is the idea. Keep the smallest plane in the main memory, fetch and compute only one chunk at the time for the larger plane. Limitation method means computing when only for a small number of dimensions. If there is a large number of dimensions, bottom of computation and iceberg cube computation methods can be exposed. Indexing OLAP data index on a particular column. Each value in the column has a bit vector. It's a bit operation into cost. The length of the bit vector of records in the base table. The height which is set of the ith row of the base table has the value for the index column. Not suitable for highly correlated domains. Indexing OLAP data. Join indices. Join index means JI or ID comma S of ID where or ID less than or equal to S of SID. Efficient processing OLAP queries, which is determine the operation should be performed on the available cuboids. Determine to which metallized cuboids the relevant operation should be applied. Exploring indexing structures and compressed dense array structure in MOLAP. Metadata repository. It is the data defining warehouse object. It has the following kinds: description of the structure of the warehouse, operational metadata, the algorithm used for summarization, data warehouse backend tools and utilities. First one, data extraction. It is get the data from multiple heterogeneous external sources. Data cleaning means detect errors in the data and rectify them which is possible. Data transformation, convert data from legacy or host format to warehouse format. Load, sort, summarize, consolidate, compute, view, checking integrity and build in indices and partisans. Reference, propagate the updates from the data source to the warehouse. Complex aggregation at multiple granularities, multi-feature cubes. Multi-feature cube is a compute complex queries involving multiple dependent aggregating at multiple granularities. For example, grouping by all subset of item, region, month, find the maximum price of in 1997 for each group and the total sales among all maximum price tuples. First, we create the select item, region, month, maximum price and some resales per purchase where year equal to 1997, cube by item, region by month or such that all price equal to maximum pricing, and find the fraction of the total sales due to tuple that have minimum shelf life within the set of all maximum price tuples. Last topic is from data warehousing to data mining. Data warehouse usage. There are three kinds of data warehouse applications: information processing, analytical processing and data mining. First, information processing. It support query, basic statistical analysis and reporting using crosstabs, tables and charts and graphs. Analytical processing means it's a multi-dimensional analysis of data warehouse data. Supports basic OLAP operations, slice dice, drilling and pivoting. Data mining is a knowledge discovered from hidden patterns. It supports association, constructing analytical models, performing classification and prediction and presenting the mining results using visualization tools. There are differences among the three tasks, from online analytical processing to online analytical mining. Why online analytical mining? High quality of data in warehouse. Data warehouse contain integrated, consistent, clean data. Available information processing structure surrounding the data warehouse is ODBC, OLEDB, web accessing service, facilities, reporting and OLAP tools. OLAP based exploratory data analysis, mining with drilling, dicing and pivoting, etc. Online selection of data mining functions, integration and swapping of multiple mining functions, algorithms and tasks. Architecture of OLAM. This is the architecture of OLAM. Mining query, mining results, then the level 4 up to level 3. How to connect the data from mining query to mining result. The OLAP architecture. Thank you.